Hi, this is Professor David Farina. In today's lecture, we're going to be discussing the terrestrial planets and the surface of Venus. Let's get started. To get us started, we have to understand what Venus is. Venus is a planet that is almost in every way like Earth. It has mountains, and it has valleys. It has many volcanoes across its surface, but what it does not appear to have is plate tectonics. Earth, as you can see in the picture below, contains vast oceans, and it also includes along its boundaries many mountain chains. These mountain chains are oftentimes related to these plate boundaries, and oftentimes at plate boundaries you include a very particular type of volcano called a shield volcano, which occurs at a subduction zone, where one plate of the Earth's crust is moving under the other. Please see a previous video to learn more. Venus does not appear to have plate tectonics. In other words, there's no plates on Venus to move around. The surface appears to be pretty stationary. And as a result, that's going to cause a lot of the features that we're going to be discussing today. Now, when looking at the planet Venus, you'll notice that this is a false color radio image, as you can see by this little box at the bottom that indicates which type of light that we're looking in. So Venus is not truly this color. We are using radar to tell you about the surface and its different heights and also its different reflectivities. This was done because Venus has a surface that is covered completely in clouds all the time. In other words, in visible light, there is no way to see the surface of Venus. We had to use radar in order to understand it. This radar map was produced by the Magellan spacecraft as it orbited the planet Venus. As you can see from this image, there are areas that are more purple in color. These are the low-lying areas, the basins or valleys. There's also very bright areas that are white and red, and those represent the highlands of Venus and are more mountainous. The greens, of course, are in the middle, and there are vast regions of mountains in the very central portions of the planet, and towards the poles, it tends to be more in the valley or lowlands. The surface of Venus is a very dynamic place with almost constant volcanic activity. Now, these volcanoes are of a different type. They are shield volcanoes, very similar to the Big Island of Hawaii. So when these volcanoes erupt, they erupt in lava flows, which is basically molten rock oozing out of the volcano. It doesn't tend to be a very explosive type of volcano, and most of these volcanoes look very much like a pancake. And you can see in the top left-hand image here, these pancake domes as they are seen. In some of these other images, you're seeing, once again, not an actual colored surface. These are simply false color images, once again, to show you different elevations. And also, I want you to note that the vertical direction here has been stretched, so this particular volcano is not nearly as tall as it appears here. This is simply to provide you with more perspective, because if we left the normal elevations, this would look like a very flat landscape. So we use this, what we call vertical exaggeration, to make it so that these images are going to give you some sense of 3 dimension. So just be careful when you're viewing these to consider that. So here's some more of these lava domes, and as you can see, there are fractures that surround the lava domes all around the edges. These fractures are due to the heaving up and down of this whole landmass as the volcano pulses with magma flows coming in and then spewing out. either emptying or filling that magma chamber below the surface. These are very large features, as you can see by the scale at the bottom here. This is 500 kilometers across, which is a very large distance. We have actually visited the surface of Venus, and by we, I mean mankind. The Varina 13 and 14 probes were sent and landed on the surface of Venus during the former Soviet Union. And the top image is what the raw picture looks like, the color as seen on the surface of Venus. And that yellowish hue that's over the entire image is due to the atmospheric effects caused by Venus's very thick atmosphere, which filters the sun's rays to make this yellowish color. When corrected for, you can see the actual surface color is more of a gray towards a black. The surface of Venus is made mostly of a basaltic magma, and by that I mean the same type of magma that oozes out of the rocks, same rock type that's oozing out of the volcanoes in the Big Island of Hawaii. Once again, a shield volcano. So all of the rocks that we're seeing here are igneous rocks. There are some impact craters on the surface of Venus, but there's very few of them because Venus is constantly resurfacing itself. The surface of Venus does not stay stationary very long in terms of its overall activity, and so most of these craters that have been formed over a very long period of time of our solar system, 4.5 billion years, have been erased. Additionally, it's very hard to have an asteroid or a comet or a meteorite pass through Venus's very thick atmosphere. The atmosphere serves to protect the surface, further lowering the amount of cratering. So thanks for watching today's video on the terrestrial planets, the surface of Venus. If you liked this video, please click that like button. If you'd like to learn more, please click subscribe. And if you'd like to get a notification each time I make a video, please click the bell at the bottom. Thanks again, and have a great rest of your day.